somehow. This is the...
remix here.
So we drag this one in and then we drag it again,
Okay, cool.
Because this is going to happen now with 2 slides.
So welcome to this Remix talk. We start now. So Remix is an IDE for Ethereum that helps developers to develop smart contracts on Ethereum and to deploy them too. So today we will give a short overview of what Remix is and what Remix proposes. Then we would like to point out some nice features that we have in Remix and that are not so much used by the community, but I think they just deserve more attention. I will then go through Remix libraries, which are a bunch of libs that developer can use to write tools on Ethereum. And then I will give a short overview of a new functionality that we will add soon, in a few months, I hope, and which is like a sort of plugins API. And I am here with Rob, Alex, and Nina. And yeah, Nina will start with the overview part.
Hello. I just now have to switch to the... maybe help. That would be nice. Does anybody use Remix already? Did you try? Whoa, wow, that's nice, a lot. And, okay. So do you kind of have a nice overview of the thing? Like you understand? But who is completely new, who never used it yet? So also like a half, okay. I'll try to go like through this main functionality for those who are new, because they will later explain like more in detail certain features, so then everybody can kind of follow along. Yeah. Just this thing has to go away. Okay. So this is Remix. The main thing you can do in Remix is to, of course, develop your Solidity contracts. So this is the main part, the editor. On the left, you can find the file explorer, and you can also use these things to like create new files, to import certain stuff. How do you close this? Like this? How do you open it again? Fuck. It's French keyboard. I don't know. This is crazy. I don't know how to use it. To open again the Safari? Okay. But Safari, below. And we cannot see it here. I have to watch it on the screen, so I'm really sorry. It's hard. So how do I close the thing? Does somebody know? What was I supposed to click? Cancel. On the other side? This means cancel? Okay. How do I do that? Below. So annular, then you cancel? I don't know. It's crazy. It's difficult to see the mouse. Yeah, wait. It's here. So put it there. Is it? Yeah. So now we have to cancel it. So this is what I have to click, right? Yeah. Okay. So let's go again. Okay. So maybe, I don't know, do you know the Remix D? You can basically connect also Remix with your local file system. So when you develop in the browser, you can basically kind of sync everything with your local system, so nothing gets lost if you by mistake close the browser. So this is this part. Then on this side, we do all sorts of stuff with our contract. So first we can compile it. Then we can search for the details about the contract. When you write the code, when you interact with the contract, you will use the ABI. So you have everything prepared here. You just click to copy. Zip. Then you can run the contract. Here you also see the errors, or like some static analysis warnings. So you should fix these things. In the Run tab, you can set your environment. So if you want to just like do the quick testing of the contracts, you can use the JavaScript VM, so everything runs in the browser. But if you want, you can actually try how it works on the network. So you can connect to the browser with your MetaMask, and then just switch to injected Web3, or you can even run your own node. So if we stay now in JavaScript VM and click Create, it will actually create an instance, which means that we deployed this contract. And we also get like a transaction log inside of the terminal. So then if you click the details, you can also see the details of this transaction. Now the screen is a little bit moved, so it's hard to show. But you can like see the status of the transaction the same as in the Etherscan, you know, if it failed or if it succeeded, and then some other details. Also everything ready to be copied. You can also record transactions. So if you want to now like prepare and click around your contract inside of JavaScript VM, and then you want to reuse it in like injected, so in injected Web3, then you can kind of save all the transactions and then reload them again. I mean, this is kind of hard to explain, but you can try it out. This is the recorder, but I think that you will show more later, right? So to interact with the contract, so we have like some functions here in the contract, and then we want to try them out. So then we can also kind of click here, and this is like a UI basically for our contract. So the pink ones are paid, so it will cost you gas to execute them, but these blue ones are actually free ones. So let's go down. So now I clicked here and I created another transaction, so you can also then see logs of these transactions. And you can again click details about it, or you can even debug it. So if you click here, it opens the debugger, and then you can kind of go through the transaction and see how it executed and where was the problem, or also like how much gas certain step used. So, okay, then some settings. You can even switch to the dark theme. We have this thing now, so this is like if you do the night coding, which we all do probably. Static analysis, they will explain later. Debugger is here, and here at the end, it's a support tab where we have our support chat. So if you're using Gitter, you can just like log in with your GitHub, and then you ask for support or something, or you can even open it in the new screen. And do you use Gitter? Gitter chat, yeah. So you find us here, and that's like a quick overview. So thank you, and I'll pass the.
Or not now?
No, I don't need. I don't need.
It's okay.
Yeah. Okay. I will just basically make a quick demonstration of the recorder feature that was already mentioned. How do I close this? Okay. So basically, what this is good for, I mean, it could be good for all kinds of things, but if I go to the Run tab, let me clear all this. So, oops. Okay, then I have now this ballot contract, which is kind of doing some voting, and I mean, it has a whole bunch of logic. But the point is, like, I can use the JavaScript VM, which is like said already, in browser only little demo, which works quite fast. And then you can just create an instance, and you use some methods, and basically you want maybe to bring your Solidity contract into a certain state. And when you have this, you can just say, in the background, the remix records all the steps that you do. So you can then just basically click save, and you can export all the transactions that happened into a JSON file. And it looks like this. So currently, we're having this is our account. So if you have multiple accounts even that are taking part in this, They will all be listed here. And then here you have basically a list of transactions. Now this is just a creation, and I executed like one method. So if you do more, then there will be a lot more stuff. And it's using here accounts, like all kinds of accounts that might be participating in those transactions, and they're all listed here. And the good thing is this is kind of fast, and it doesn't cost anything, and you can record maybe a very complex setup. And then when you finish and you saved it, you can switch to, I don't think that we have MetaMask installed here, but like if you then switch maybe to a mainnet or even a testnet where even the transactions take longer, you can open, once you switch to the network, you open the JSON file, and then you can click play on the different network, and it replays all the transactions on the other network that you chose. And this can maybe be quite handy, because if it takes longer... Sorry?
It doesn't contain the contract deployment transaction, only the ones you pick up. Or will it also contain the
yeah, the first one, for example, is when I click the button create, it created the first transaction, so this will also be included. So one thing that you have to do actually when you switch to the different network, you get a different address. So you have to go here and replace all the addresses, but just up there, because below it will automatically use those that you set on the top of the file. And yeah, maybe this could be quite handy. That's actually already it. The thing is, because it records everything, if you want to open a different contract and start over, you should first click this button to clear all the transactions to start again with what you will do next. Yeah, that's basically it.
Excuse me.
Sure.
Can you, so everyone can...
Can I also import an account to the JavaScript VM version? Because I mean, obviously, for certain cases, I want to use the same account in my injected provider as well as the JavaScript VM provider.
I don't know. No, I think
That definitely should be added.
So yeah, I think usually when you switch to another network, you get a different account. Like if you use MetaMask, then it will just use the address that MetaMask.
Sure, but what you would do then is you would take, for example, you would generate a test account. You would have in MetaMask a test account, and you want to import the private key to the JavaScript VM as well. So like just having a feature to import accounts definitely makes sense.
Okay. So you mean that like when I have the address, I will automatically populate all the addresses here, or?
No, you actually use the same address on the injected provider as well as the VM provider. Because for certain contracts, it's important which kind of account you use, right?
Okay.
Let's say you have some hard-coded owner or so, then you need to have the same address.
I see.
So you have to have the ability to import accounts into your JavaScript VM.
Sure. Yeah, I think, do we support that yet? No, I think this would be something that we should think about. Cool, thanks.
Can you import that file once you have that?
You mean the JSON file?
Once you've saved the transactions, you want to recreate it. How do you reload the file?
Yeah, exactly. So you can, you can save it to. You have the file explorer on the side, so you can save it on the local disk or in the browser storage or wherever.
Yeah.
You can also just copy paste it from somewhere and open a new file.
Yeah.
And then when you open the JSON file, you can immediately start using it and replaying it with a button.
Okay.
So yeah.
This may be a little bit tricky from the UX perspective, because like I wouldn't be clear to me that pressing the play button now is playing that left file,
Yeah,
right?
we should definitely improve on that. So it's still the Remix Alpha branch. Yeah, we will work a little bit more on it. Yeah. Okay. So I pass the mic.
Somewhere deep in the slide deck. Should I just go? So recently, well, not that recently, but I was trying to import some Zeppelin contracts and a Dharma contract into Remix, and I didn't know how to do it exactly. So I just put it down to I imported it to my computer, and then with Remix, I found with the File Explorer, I found those files on my computer, and it took a lot of time, and it was kind of a pain. And then I realized I need some help. Okay. Where are we? Realized we could load. Yeah. We can load files from the console. So can you even read this? Yeah, you can load files with, I think you can't see the commands here, but it's remix :load URL, and then you put the GitHub URL in the bottom here. And as you can see on the File Explorer on the top, then the GitHub repo loads. And all the dependencies load as well. And then you can even make a batch file, like at the top where it's, you have a whole bunch of remix load URL lines at the top. And when you select that in the code editor and you just type remix :batch, it'll load all those files. So it was a big time saver. And that was the end of my frustration as soon as I discovered that.
Thanks. Okay, so there is one other nice feature that we have added recently. And basically, you could debug transaction from Remix, but it was a bit of a pain to debug transaction from the mainnet. And now it's just possible. So I will just go through some slides. Let's say that you are in Etherscan, and you can just take a look at some transactions. Here we are seeing one Lambda contract. You have, the contract source code in Etherscan too. So you can just easily copy the contract from Etherscan, and then you will just paste it in Remix. And then you go to the debugger tab, and then you can just fill in the transaction hash in the debugger tab, and then you can start debugging. I mean, it's kind of easy features, but I would say that we made like 1 year, or it was quite long for us to arrive to these steps, and we are pretty proud to have it because it's kind of very important. So now you can easily debug transaction from the mainnet, and you can do that also while having source code debugging. So you can follow the execution in the Solidity source code, and you can follow the state changes, and you can follow also locals changes. So it's kind of nice. And we will also add the same for Robston, Kovan, and Rikubi. So pretty cool. There's basic features of Remix static analysis. So we have this since a few months here. And basically, as you write contract, as you compile contract, Remix will warn you about some stuff on your code that might be improved. So if you take a look at the second one, for example, it will warn you of some potential reentrancy bug. If you look at gas and economy, you will see some kind of warning that can help you to save gas. So it's a bunch of modules that you can run, and that will help you to have a better code. So this is very, very important, and you have to follow them. Yeah. So we have a terminal in Remix, and basically you can input Web3 object in this terminal, and you can make requests to the network. So it can be used when you develop contract, but I really think that we all, I mean, us too, should use it when you want to maintain contract. So let's say that you have your contract live deployed, and it should be easy to just paste some script that will be executed in the terminal, that can run some tests, some check, and that can just verify if the contract is healthy. So it's something that we have still to work on it. It's not fully done. You can use it, but yeah, we have to improve it. So then you will just paste script, run any kind of JavaScript script for checking if the contract is healthy. So it's very important. Remix libraries. Yeah, so we had a repo last year, and the name of the repo was just Remix. And basically, this repo will just contain everything, every kind of helpers, every kind of libraries, every kind of debugger tools, and so on. And during DevCon 3, we had this, not protest, but we had some people were saying, yeah, Remix is nice, but then it's not so much usable for devs if they want to write tools, because you just have to clone the whole Remix repo, and it's much more better if the Remix repo can be split in several modules. So now, instead of having this big Remix library, we have several libraries. We have Remix lib, which contains some helpers. We have Remix core, which contains some like trace manager, code manager, and stuff that can help you to write your own debugger or help you to write your own tool on Ethereum. We also have Remix Solidity. Remix lib, Remix core here. Remix Solidity, which contains like the static analysis module. So now it's easily possible to use this module in other tools. And it's kind of important, and this is the point of our work here, to build modules that dev can use later on. So we have static analysis, we have state locals decoding, and then we also have some helpers to help developer to compile Solidity code. Yeah. Then Remix Debugger is just some kind of user interface that wrap everything in a single interface to debug transaction. Then we will soon have Remix Test, which will add some unit testing in Remix. Yeah, now we move away from these Remix libraries, and I will just speak a little bit about plugins API. So basically, we have some tabs in Remix, and we think that it can be interesting for the community to be able to write plugins that will be usable inside Remix. So I'm just thinking about some tools that already exist and that are used by the community, and we should just be able to integrate those tools in Remix. So there is a lot of linters in Solidity, there is a lot of fuzzy testing in Solidity. There is many tools that do many things in the ecosystem, and our goal too is to bring some of these tools in Remix, so we can have like a nice and a strong IDE. So this plugin API just add a new tab in Remix, which will be like developed by external project, external team. What will be this API? So basically, one plugin can access the compilation results to run some other static analysis warnings. One API would be able to analyze the source code of Solidity contract to improve the linting or just to warn the users about best practices. And plugin should also be able, maybe, we will see if it will be, but I think it's nice, that a plugin should be able to listen on transaction and then to be able to run some fuzzy tests on top of transactions. And then we can have multiple tools that the community can just write. So this is the access part of a plugin, and that will be like the changing part of a plugin. So basically, I think that a plugin should just be able to maybe to change the content of the editor, to update the linting, maybe, but not to do so much. So basically, a plugin will just listen on inputs from the users, will just analyze these inputs, and will just produce some warnings and some helpers to the users. Well, so as I said, we are kind of working with the community too. We have a lot of contributors that are working with us. We are like, I think, 4, 5, kind of 7, which is nice, like fixing bugs and writing new features. In the next few months, we will be just improving the way you can debug transactions in testnet, Kovan, Rikubi, and Robsten. We have, since 2 weeks, a way to run Remix locally. Remix has been wrapped in one Electron app. This is the second line here. And some people are also working on VS Code integration for Remix. So there are 2 issues, and they are both working on different aspects of this integration. So they just want to bring a debugger capability inside VS Code. What's next? Oh, okay. So, so look at the modularizing stuff. It should be struck. It is not. It's a mistake. So this stuff is a slide from Cancun. We had to do testing, publishing, and modularizing. Testing is now in progress, thanks to Yuri Matthias. Publishing is still something that we need to improve and need to do. This is basically a way to package contracts and then to publish them. We have not already started to work on this. And modularizing, well, we kind of did that already, but we also need to improve it. So yeah, we have just one thing that is in progress and one thing that is now struck, kind of done. So I think we are just keeping going further, and things are going, I think, well. Yeah. So this is for the what's next. And then I would like to thank all of us, like Rob and Nina and Alex, for coming in Paris, and thank you very much.
Just one thing, on Saturday we have a workshop, so if anybody wants to kind of try how this works, if you're new, come and join us, but if you already have your project, we can help you solve some issues if you're having them. And if you have questions, unfortunately we don't have time, but you saw the chat, so ping us there and we're glad to help. Thank you.
I hope none of you guys need a break today. I don't think you will get one. What did you do? Did you log
I
in
just
or-
logged in my account. I'm logged in my account there. On this this one.
And
I'm
now
logged in.
When he gives you the signal, we go because we're live stream, okay?
For sure. I mean, at least.
Gonna be at least a half hour.
Sure. Next person.
Is that loud enough? Very good. Hey everybody, my name is Bjorn Wagner from Parity Tech, and I have the pleasure to tell you a bit about one of our newest systems, which is... Hold on. I was told to hold on for a second. Okay, got it. Awesome. So I have the pleasure to tell you a bit about one of our new systems. It's called Parity Bridge today. Over the next half hour or so. So please bear with me. Sorry for taking your break, maybe, if you stay here. And I hope I'll be able to show you a demo as well. But that's not quite clear if that's possible because of the tech setup here. So Parity Bridge, right? Just a bit about the background. As some of you might know, we have been working on a next generation blockchain protocol, which we call Polkadot. It's a kind of a multi-chain framework, and one part of it is the system that we call Parity Bridge, and that's supposed to allow Polkadot, this multi-chain network, to connect to independent blockchain networks, such as Ethereum. So, such as a network that provides its own means to come to consensus, its own connectalization mechanism, rather than these other elements which we call parachains, which lend its means to come to consensus from the Polkadot network. That just as a background. And Parity Bridge is really the project that is prototyping such a system. And along the way, we figured out that it could be very useful right now for other things. So what problem could it potentially solve right now? As many of you know, right, and I would be really interested to find out later how many of you here are Dapp developers and have been working on certain Dapp smart contracts and so forth. As many of you know, we are confronted with the problem that the Ethereum mainnet still doesn't scale, even though we've been live since 2015, summer 2015, and it currently doesn't look like the Ethereum mainnet will scale for at least another 12 months. And I know this is a rather difficult discussion, what means scaling and so forth, but we just had this wonderful meetup in gathering in Barcelona these past 2 days with a lot of teams that work on scaling solutions, rather near-term scaling solutions, or mid-term scaling solutions such as the Plasma team, L4, that counterfactual that works on state channels, Raiden and so forth. And it really turned out that none of these solutions that people are working on will, like the rather good solutions, will be available for at least the next 6 to 12 months. And what we see is that there are quite a few projects now that have been working on their dApps for over 2 years. And they are in a state where they have written up their smart contracts, they have tested them on a testnet, and now they really want to go to the next phase. They want to deploy it and test some user interactions with real value, because the user really, really interacts differently if real value is involved or not. And just to name a few of them, there's Giveth, there's Colony, there's Gnosis, that are all pretty much ready to go live, but they can't for 2 reasons, right? And they are obviously interconnected. One is the high transaction costs on the Ethereum mainnet. I mean, if here I put some statements from blog post or like just from my conversations that I had over these past 2 days, if Gnosis, any trade cost $1, that's not really viable. Neither is what Giveth is trying to do good, and then you have to pay $11 for creating each milestone. So that's a real problem that these Dapp teams are confronted with right now. And there are pretty much only 3 options for them, right? So either they stop working now, they say like, hey, you know, I'm going to wait for another 1 year or 2 years or whenever the mainnet is ready to scale, or maybe, you know, I throw away all my smart contracts and think about how that could work with state channels, because state channels require a very, very different way to architecture Dapp. Well, or you deploy on a testnet, but then you are left with the issue that you don't have real value there and can't really test user behavior. Not to talk about all the network congestion that we've seen from all the ICO craze and CryptoKitties craze. So, what can we do? Parity Bridge, what is that? Right? Parity Bridge is a federated bridge between any 2 EVM-based chains, networks, that relays arbitrary messages from one chain to the other. It connects 2 chains, right? We call them home and bridge. And the bridge really consists out of, I would say, 3 parts, right? One part is Rust software that connects to 2 Parity Ethereum nodes, each running one of the 2 chains, home and foreign. It consists of 2 deployed EVM contracts, one on each of these chains, right? And the nodes track any events in these contracts and interact with these contracts. And last but not least, entities in meat space, which we call authorities, that run the system, that run these nodes, the bridge software, and validate and relay messages between those. Functionality, what does it provide, right? It allows actors on one chain to call any function with any parameters on the other chain. And its security relies on authorities that run the bridge and the other network. So authorities have to be trustworthy, but the overall security of the system can be equal to the foreign chain security, so the security trust model that's behind the other network. And that is mainly because all relays between these two chains have to be signed off by any authority that is running the bridge. So they see transactions saying like, hey, I want to relay that message. And they look at them, validate them, sign off on them, provide a signature. Once enough signatures have been gathered, this relay is being fulfilled. And we try to keep it as simple as possible, simple abstraction, don't put in too much fancy stuff, and we want to get to a state where it's so flexible and general that it can really cater for any potential use case that people would have on each side of the chains. So how can that mitigate scaling issues that we have right now? How can that help Dapp teams that are in a state where they have contracts that they want to test with real Ether? Well, two things, right? We can offload the transaction load to another network. And since we already have networks, proof of authority networks, that provide more throughput than what is possible on the Ethereum main chain, that can really help. Currently, we can provide a throughput that is 10 times to 100 times higher than what we have on the mainnet. And also like additional features or additional improvements such as lower latency, lower block times, faster finality. Right? On the Ethereum mainnet, you usually wait at least 12 confirmations before you consider something, you know, relatively final. In a proof of authority network, you have a different model, and you can be sure that something is final on that particular network way earlier. So how can that help mitigate the scaling issue? Well, you could potentially, if you can call any function on the other network, you can spread up your Dapp to 2 networks, right? And I want to give you a few easy examples that came up by talking to all these Dapp teams over the past days, weeks. For example, look at Givers, right? Givers have a Dapp that allows users to donate for good, and then take some decision-making process how these funds should be used, how they should be allocated, right? So there are 2 parts of it. Number 1 part is deposit Ether into the Dapp, and then take some decisions based on that later on. So the real value, the Ether, right, the Ether that has real value is locked in the Ethereum mainnet. That doesn't exist on the testnet. Now, if you have a bridge that allows you to wrap this Ether on the real mainnet in the sidechain, let's for example say Coven, right? Suddenly you have a wrapped Ether token on Coven. Then this can be handled just as real Ether on the main network and has the value, right? So what you could do is like, Givers could say like, hey, you know, one part of my Dapp lives on the mainnet, and most of the other parts live on this other network, for example, Coven, where all these transactions happen. So I save a lot of transaction costs because transactions are cheap on Coven or currently for free, right? And there are different examples, right? On the left side, you see the ETH to ERC20 use case, right, where you wrap Ether on the main chain and have has the wrapped Ether as ERC20 token on the side chain. This is relevant for a few projects. Another one is where you have an ERC20 token on the main chain and you just relay, like deposit it on the main chain and make it available to the same user who deposited on the main chain on the side chain. Let it be Coven. And the user can do whatever he wants with that wrapped Ether on there. So that is very interesting, not only for example, Swarm City, Dragonerium, but also for somebody, potentially somebody like Radar Relay, right? Who, where you could assume that the user, right, wants to use the Dapp quite often and only deposit once and withdraw once over a certain period of time, and in between do a lot of trades, right? And that would be really, really expensive on the main network, but if you split your Dapp off, you only have 2 transactions on the main network, the deposit and the withdrawal transaction, and any other trade on the side network. And there are a few other use cases where you need some more custom solution, where you need this arbitrary messaging function rather than just wrapping Ether and making it available as ERC20 token. So this is where we want to get, and we are pretty confident we can get there in like 1 to 3 months, I guess. And I just want to talk about the current state of the solution that we have, the current state of Parity Bridge. So the current state of the Parity Bridge is an ERC20 token on one EVM-based blockchain that is backed by Ether on another EVM-based blockchain. And we currently have that deployed and running on Robston and Coven. So there are a few assumptions we take. Number one, the assumption is that the home chain, which would be probably the main network, has higher transaction costs than foreign, and foreign uses a POA consensus mechanism. For multiple reasons. One of them is obviously the authorities should be able to make free transactions. And the other reason is if the transactions costs are not lower on the foreign network, obviously you don't gain anything. Therefore, we tried in our solution to minimize any transactions that would happen on home and try to offload all the transactions in the bridging process to the foreign network, in that case, Coven. The current solution is built so that the bridge authorities, so those that come to consensus and relay transactions, are immutable after deployment. So we have a fixed list of authorities in the contract when we deploy it. This can be fairly easily be extended to with some kind of governance process. For example, you could have a majority vote where the authorities say, hey, I want to onboard this and that project to also be an authority. And I will talk later a bit about where we want to get eventually. What happens is the user deposits Ether into the home bridge contract on home and gets the same amount of ERC20 tokens on foreign. And users on the foreign bridge side, so on Coven, can use the wrapped Ether just as any other ERC20 token. And last but not least, relays between the chains happen in a Byzantine fault-tolerant way. And this is a bit of a wrong usage of that expression, in my opinion, because you usually rely on, talk about that in consensus systems, but in some way or another, it's more true than false. Just to show you roughly how it works, right? Here, see on the left side the home bridge contract. The user sends a transaction that deposits Ether into the contract. There's a breakout event. The bridge authorities listens to that event. They track them. They see it. Then they validate it, provide a signature, sign this event, provide that, send that to the contract on the foreign side, on Coven, where transactions are very cheap, right? They are gathered there, and once a certain threshold of authorities have provided their signatures, an event is triggered, and the ERC20 token is being minted. And the same way around, if the user wants to withdraw their Ether from, their wrapped Ether from Coven to the mainnet again, a similar process happens, just that all the signatures are again being gathered on Coven rather than on the main network, because transactions are cheap on Coven. So, in what cases can that be useful? This particular state of the bridge, right? Like, who should be really interested in that? In my opinion, any Dapp, right, that has users that want to send any kind of Ether to an app and then do more than 2 transactions, interact with the Dapp more than 2 times between any deposit and withdrawal. So I asked around a few projects, and for example, CryptoKitties told me that's roughly for them 10 to 100 transactions per user, right? A user provides some Ether, does a lot of things, you know, trades, whatever, puts hats on, I don't know, and then withdraws the Ether again. And there are 10 to 100. So that is a lot. You can save a lot of gas, you can save a lot of costs. Same with any kind of gambling app, and similar with Giveth. It would be the same case. A few UX considerations obviously apply. Number one, right, if the user keeps interacting with the Dapp, right, he sends the Ether, he needs to be on the main network. while sending it. So MetaMask, for example, if you use MetaMask, has to be set to the main network, and then once the deposit is being made and the wrapped ether is being made available to him, he has to switch MetaMask to the other network and interact with that. Pretty straightforward, right? And the second consideration for sure is users need to own native currency on the other chain as well, which is kind of unfortunate. So, roadmap. Where do we want to get? What do we want to change? Number one, thing where we want to get quite fast is we don't want to have the bridge authorities be a fixed set that we have to determine when we deploy the contract, but rather we want this set to be tracked. We want the bridge authorities to track the set that maintains integrity of the POA network. So as all of you know, a POA network, right, has a validator set that that comes to consensus and provides a finality mechanism for the other chain. And we believe that the trust model is pretty similar, right? If the user wants to use a Dapp, he has to kind of trust that not a majority of the POA networks authorities collude against him and forge any transactions. And in the same way, the relay between the networks has a similar trust model. So it really makes sense that these two set of parties are the same. So if you imagine, like on Coven, right, we will get to a point where we have dynamic validator sets. That means that, for example, currently there are 9 authorities, 9 Dapp teams, right? And they decide, hey, we want to onboard another one. They do a majority vote. This one is voted in as an authority to maintain integrity of the POA network. This same authority should be onboarded as a bridge authority as well. So this is one part where we want to get over the coming month. Another one is abstracting over the special use case from ETH to ERC20 to arbitrary message passing. And I just want to point out one really cool use case that came up when I was talking to one of the maker guys 2 days ago, which is, imagine you could set up a new POA chain, right? A new chain, or potentially even Coven, and have the native currency on that side chain be DAI on the main network. So a user who sends DAI on the main network to this bridge contract gets native currency on the other one, so Ether. So you would have a stable coin as Ether on this other chain. I think that's quite cool, and we have an idea how we can get there quite fast by allowing the bridge system to enact state changes on the phone chain. So I'd love to show you how that actually works right now and walk you through that. But as far as I was told, this is not possible because they have you don't have Chrome, right? You only have Safari and no MetaMask. So the only thing that I can actually do is show you a few things that we have built around that. So does it work? Yeah, how can I show that somehow?
Yeah, sure. It's Safari, right?
Yeah.
So just drag it on this screen.
Up?
Yeah.
No?
On the right. Should appear. Yeah.
Woo.
Okay.
Here we go. So what we have, for example, is a dashboard that tracks whatever happens right now on our deployed initial version between Robston and Coven. So you can see, for example, the status that shows you just like some information from the contract, which is, for example, how many signatures are required for any relay, right? We can configure that. It could be 10 out of 10. It could be 7 out of 10 authorities need to provide the signatures. Here it shows the authorities. Currently, we have only one. This is our node that's running. The estimated gas cost of a withdrawal transaction on the main network. We have limited how much Ether can currently deposited in a single transaction, as well as the max total balance that can be held on the main chain side of the bridge, just for testing reasons, security reasons. We don't want to have a fuck up, as you all can imagine. And I think these failsafes are quite sensible. But this is all configurable. So whoever here feel free to set up your own POA network, just deploy the bridge. You can do a lot of cool stuff with that, I think. Or just test it between Robson and Coven. And we would love to deploy that between mainnet and Coven at some point, or mainnet and maybe another new network that is a bit less of a testing network, so that, for example, the dApps that want to use this kind of scaling issue mitigation strategy could have a bit more confidence that there will be no breaking changes. So what we've been talking about in Barcelona, for example, is like, there could be, some teams have voiced that they might be interested in setting up a new POA chain where they do a few pledges. Number one, they say like, hey, you know, this is kind of a test network, but we say like, hey, we have real value on here, maybe limited value, but real value. We don't want to try really cutting edge features such as Casper network, right? We need our Dapp to be running over the next year. So that, and second of all, which I think is really important, that everybody would do a pledge and say like, hey, you know, we acknowledge that it's not the vision, the future where we want to get, because, right, a POA network is not why we are all working here, right? But to be honest, this is the only way we can see how Dapp teams can actually test user behaviors with real value right now or over the next 6 months. So it's just, in our opinion, a fair approach if teams decide to do that. But in my opinion, it makes sense that you do a pledge if you decide to go down this route and say like, hey, you know, I'm actually committed to the main Ethereum network, or like a full permissionless system, and like this is only an intermediary step to get where I want to get. And you can check that all out in our GitHub, right? It's all open source, Parity Bridge. There's a user guide as well. There's a deployment guide. This, I don't know if you can see it. This dashboard is live as well. You can watch the, yeah, it's a bit hard to see here, but basically what you see is like when a deposit comes in, here it shows you how many, what's the block depth of that transaction, so how many confirmations have we seen. Once there are 12 confirmations, for example, the first authority says, oh, great, right? I've seen 12 confirmations, so I say like, hey, this relay should happen, I provide my signature. So in the middle you see that is the one Parity node that's running currently, the bridge node, but there would put probably, like there should be like 10, 20, however you want, and once a certain threshold has provided their signature, the transaction actually happens. And what you can do is you can track that all on Etherscan, so you can check it all out. The contracts are all verified, so you can read the source code. Here's Homebridge. You can actually interact with it. Yeah, that's pretty much it. And now I would love to take the time and take any questions you have.
Thank you very much. Just a small question. You mentioned it's all networks that EVM based, right? And definitely there are a few more projects that EVM based and derived from Ethereum. They will be compatible with this bridge as well, or it?
For example, other networks.
Ethereum Classic, or?
Say again. For example, POA network, right?
No, but Ethereum Classic.
Of course.
For example, is
I wouldn't
EVM based.
I wouldn't see why not.
Yeah, Ubiq or.
Yeah.
Okay.
I mean, does Parity currently supports Ethereum Classic?
Yeah.
So that should work, yeah.
Okay.
I don't think they did any changes to the EVM that should break that system.
If the EVM is not changed, that means if the EVM is not changed, that means it's compatible with the bridge.
It should be, yeah.
I see. Okay, thank you.
Could you use the same technology to bridge different blockchains, so not Ethereum based?
Well, in the future, it's meant to do that. For Polkadot, right, we want to bridge, for example, Bitcoin to the Polkadot network, but that requires a lot of modifications, obviously, because these authorities, like currently, right, how it works, it's pretty simple. You have kind of a multi-sig on the main network, right? And in Bitcoin, you have a lot of limitations currently. For example, how many participants you can have in a multi-sig, right? But we are fairly confident if, for example, Bitcoin moves over to a different signature scheme, for example, Schnorr signatures, where the size of the final signature doesn't increase with all the signature authors, then we could potentially get there and achieve that. That has yet to be seen. But in general, any kind of smart contract-enabled blockchain should be able to be bridged in the future.
But do you have any roadmap for other blockchains? Or not
currently, non-particular. So, right, obviously, Ethereum, all EVM-based, which are supported right now. But there are not many other smart contract-enabled blockchains that are up and running right now. So it's kind of difficult to say. I don't know enough about the Neon execution environment to talk about that, but I'm really happy to like discuss that or look into that. Even though it would be quite hard, I don't know if I would want to do that because in terms of consensus mechanism, the guarantees the Neon network gives you right now, I'm not sure it provides you the guarantees that you should have to make value available on another network.
Okay, thank you very much. I got a small question too. Is it
thanks.
Is it possible to build a bridge between a private and a public network?
Of course. So what is a private network? That's a good question. So like the way I talk about it is usually the following, right? You have public networks and private networks, which means public means anyone can connect to it and look into it, and private network is more like a VPN network that nobody can connect to. The other dimension I would usually discuss about is like permissioned, unpermissioned. And there are so many different levels and layers where you can permission a blockchain system. For example, who can connect to the network, who can't connect to the network, who can participate in the consensus mechanism, right? In proof of work, it's really unpermissioned, that level. In proof of authority, it's a bit more permissioned, right? Because the current authorities have to onboard any new authorities. But if that's what you mean, with private network, then obviously, and that's what we talk about. So you could have an enterprise network that says like, hey, you know, I want wrapped ether. I want ether value on my chain. And you could make that happen with that exact solution, yeah. If that answers your question. Yes, please. Oh, sorry, yeah.
So firstly, this is a great effort, and it is actually a pain point that you are really targeting. So my question would be that a transaction, an ideal transaction, would just do a withdrawal or a token-related transfer in the mainnet, and the rest of the transaction could be carried out on, suppose, say, Coven. So doesn't this bring a loophole in security for the transaction? So because there's a bridge between different networks, doesn't this bring in a security issue?
Well, we got to be we got to be very specific about that, right? So once you offload transactions to another network, right, these transactions are secured by the other network. So these security or the security considerations of the other network applies to your transactions. But if we talk just about the relaying mechanism, right, it's pretty straightforward. Let's assume the authorities of the bridge who relay are the same authorities as the ones that secure the other network, right? And you require a majority or supermajority of authorities to provide their signature to relay any kind of transaction. Then you kind of get the same security guarantees, right? Like none of the authorities can like just steal ether or any kind of other stuff. They can't forge transactions anyways. They can't forge a signature, as you know. And Yeah, does that answer your questions? Or?
Yeah, the question was that I want that transactions X, Y, Z should be carried out once this amount of Ether has been deposited on the network. So, you know, the connection between the two transactions, that this has to follow the first one.
Okay, got you. Well, so if you deem the security model of the site network trustworthy, right, of like this POA network consensus mechanism, and the bridge security model follows that one, then, and you say like, hey, you know, the user sends a transaction to this other network by providing some ether and some kind of calls a function. Says, for example, when my ether is wrapped on the other side, do this, that, and that, and this is a transaction. Yeah. And you trust the security model behind it, then this will happen on the other network. The message will be relayed, and once it's relayed, it will be executed on the other network. And there are a few things around it, like we designed it in a way that even if the authorities, so what happens is the user calls, like kind of makes, says like, hey, you know, relay this message. Then the authorities gather the signatures, and then in the end, someone has to submit another transaction saying, hey, here are all the signatures, so this is valid, do it, right? And even if none of the authorities do that last step, if that would happen, the user could do that. The user could trigger that himself, right? So in that particular case, what you're talking about, I don't see any security considerations beyond what you would have concerning a POA network, or the collusion that they collude with each other.
Thank you.
Hi, I was wondering, is possible with the Parity bridge basically to do some kind of like child chains? So you get a bridge from the main to the child, and from the child to another child, and so on, or is like one A to B?
It can connect, it can relay messages between any two Ethereum-based networks, right? EVM-based networks. So there is nothing that speaks, again, like having one network connect to the other and this network to the other, but there's one thing. The current design assumes that one of the networks is a high-value, high transaction cost network, and the other one is a low transaction cost network. And specifically, it assumes that the other network will, or that's where we want to get, will have some means to come to finality, not like probabilistic finality in proof of work, but rather like determinate finality on a POA network, so that at some point you can say, oh, right, this is really final, and speed up the relay back. Okay. But potentially not, and POA network is actually looking into that because they want to connect a lot of POA networks with each other, and they're using Parity Bridge and building on top of that. Okay. So nothing that fundamentally speaks against it.
Okay, thanks.
Yeah, of course.
Hi. Maybe I'm missing something here. My question has to do with volatility. If you're depositing Ether on the home bridge, to what extent can volatility affect the token that you get on the foreign chain?
Could you repeat that?
Sorry, yeah, my question has to do with volatility. If you're depositing Ether in the home bridge, in exchange of which you get token on the foreign chain, yeah. What happens if the Ether that you deposited, like the value drops 70%? Is that a risk? Is that?
I mean, so the bridge just makes sure right now that one Ether, like one ERC20 token, like the bridged Ether on the side network, is backed by exactly one Ether on the main network, right? So at any time, like it doesn't matter who sends, like I could, for example, deposit Ether on the main network, get the wrapped Ether on the side network, send it around to somebody else, and it doesn't matter how many transactions there are in between. This exact Ether, bridged Ether, will always be backed by one Ether on the main network. That's the guarantees that the bridge provide you with. So right? Same volatility, except you have, for example, you use DAI, right? If you would bridge the DAI over to the side network, it has the same kind of volatility constraints as anything else. So, yeah, it's nothing specific to that. Any other question? Okay, I would be. Oh, yeah, there was another question up there.
Okay, the last one, and then you can continue on the Slack channel maybe.
Yeah.
It's good for me.
I am wondering what do we need to run to have a bridge between two blockchains? Like, do we need to run something, or we can connect to existing validator?
So, as I said, right, for example, currently this is deployed between Ropsten and Coven, and you could just use it, right? Connect your Dapp, your smart contracts to these, make them interact with each other, and like use that system. Or you say like, hey, you know, I want to use a different POA network, or I want to set up my own POA network, or I also want to be a bridge authority, right? And then if you want to be a bridge authority, obviously you have to run code. You have to run these two nodes in order to be able to provide these validation function. Yes. I would be interested to find out if who of you are Dapp developers? So actually developing that. Who of you actually have the problem right now that they are in a state like where they could potentially deploy something, but it's too costly? Oh, that's a lot. So like, who of you think that even the current state of that, so the current state is ETH to ERC20, can help you guys? The current model where you deposit Ether on the main network and you get a wrapped Ether token, so an ERC20 token on the side network. Who of you think that would be enough already? Okay, cool. Okay, cool. Who of you think that if, you know, it would provide the function to transfer arbitrary messages between these two networks so that you literally can just split up your Dapp contracts as they are right now into two parts, one that runs on the main network, one's on the side network? That would solve it. So these are a lot more, right? So 1 to 3 months, and I would love to see you in our channels here. Ah, you can't see it. So we have a GitHub channel, Parity Bridge. We have a Riot channel, Parity Bridge. And obviously the Parity Bridge GitHub repository, and it would be really awesome to get in touch with you, hear your use case, and figure out how we can cater for that use case. Thank you so much.
Jason Carver.